Hi there, welcome to this first webinar of four with the Soil Food Web. And today our topic is soil health and the importance of global ecology. So, Carla, isn't it great to be back with another series?
Yes, it's always great. We keep counting the days and times for being here, so it's an honor to be sharing this time with you again, Nick.
Fantastic. So we have some do's and don'ts, some rules which Carla will tell us all about.
Yeah, so as you guys remember, and we love you for that because you were an amazing community. Thank you for all your energy and presence. But just to make sure that the newbies are be up to date with our instructions, we ask you to keep yourself muted during the session so you be able to get the best sound as possible and help others to receive the same quality of sound. If you have questions for the panelists, please use the Q&A session in the Zoom. It will be located at the bottom bar of your Zoom window. And if you want to have some closer interaction with the attendees and pay attention that Didi will ask you as well to put some answers on the chat, use the Zoom chat for that. Use the chat to to talk among yourselves, sharing experiences, sharing ideas, but pay attention that Didi we're going to have specific exercises. And as always, do not forget to have fun.
Brilliant, Carla. That's fantastic. And also, we can also add that if you missed tonight's webinar or you want to go back and look at some of the fantastic webinars we've put together, you can always go back and look at it on YouTube and the other social media sites. So please do and enjoy yourself. So, without further ado, what Carla and I are going to do is run through tonight, and we're going to start off by introducing our guest speaker. Didi, over to you.
Okay, hi everyone. I am the author of two books. One is called The Ecology of Care. The long subtitle of that book is Medicine, Agriculture, Money, and the Quiet Power of Human and Microbial Communities. And you'll hear the story of how I went from writing that book to a book called Understanding Soil Health and Watershed Function, to working with millions of farmers around the world, and including many of you.
Great, thanks, Didi. Carla, tell us a bit about
Hi.
yourself.
Yeah, I mean, at this point, a lot of you know me. I'm Carla Portugal. I have the honor to work with Dr. Elaine in the school for almost 6 years now. And I'm a biologist by background and went through the path of environmental sciences slash engineering with soil restoration around the globe. And my passion is to, besides the field work, is to connect with our students, help translate all this knowledge that we have spread around the globe and make that in a way that we can really help make the change. So being here at the school helps me fulfill a big chunk of my journey. And what about you, Nick?
Thank you, Carla. So yeah, I'm a farmer from the UK, and I farm at Wild Ken Hill. I have my own business called Wild Soils, and I got engaged with the Soil Food Web about 4 years ago now, and I have the absolute privilege to work with the school and these amazing mentors we have, and working closely with Carla and the team. It's really great, and it's so lovely to see all these amazing people joining us from all around the world, isn't it, Carla?
Yes, yes. We are still waiting for someone from Iceland, but we're pretty close, Nick.
Fantastic. So I'm going to just let you all know what the first webinar will be all about. So we're going to look at the connection between the global ecology crisis and the soil health. Come on, it's remarkable how so many of these issues, such as climate change, the flooding we're seeing, the wildfires, the pollution, the of our watercourses and rivers and oceans, along with food security, can largely be addressed by altering our approach to managing the world's soil, and how regenerative agriculture is such an important change that we need to make. And you'll hear from her in a minute, but we are so excited to have soil health advocate, author, educator Didi Pershouse with us today, who will be exploring these connections between soil, planetary, human health. So that's that. Who we got next up, Carla?
Yeah, so on webinar 2, we will continue this journey that we're starting today with Didi, and we're going to have another beautiful set of panelists. They are change makers in the regenerative movement. Nicole Masters, who is a world-renowned agroecologist and who has worked with farmers in several continents, helping them making this transition to regen ag. And Nicolas Netien, who is also an agroecologist, and a permaculturalist. And he holds the world record for polyphenols concentration in olive oil. I can smell from here, literally. It's just like, I still need to taste, but I can imagine how magic that is. And his product is a super powerful anti-inflammatory currently being used by sports professionals to reduce recovery times from injuries. And he's going to be telling us all about the health benefits of his wonderful product, which Dr. Elaine used in the past as well, back in 2019, right, Luke? And he has a beautiful announce. I'm just going to give a spoil. We're going to be able to order his olive oil from whatever place in the world we are. So I'll be able to test his olive oil finally. He's located in Cyprus, where he's going to bring us a lot of case studies and data about his work and his beautiful journey. And he's using soil food web method in his property, his olive oil. So stay tuned for webinar 2. And after that, where are you gonna go, Nick?
So we're going to go and look at our step to rapid soil regeneration, which is something that we're trying to do here on my farm in the UK. So we'll be unpacking the soil food web approach in 3 easy to understand steps. And this is a great opportunity to understand where these process works, where we find how we can harvest beneficial microorganisms from our local area, and how we can multiply them using Dr. Lane's scientific composting methods, and how we can then apply them to the soil and also to plant foliage throughout the growing season, giving the soil biome a boost that literally brings soil back to life. So this is a great webinar for anyone who is new to the soil food web. Carla, what do we got finally? The last one will be what?
It will be, it's back. We're gonna have another house party. I'm excited for that. We're gonna have the whole team back to interact with you. You're gonna have a chance to interact with our mentors, but it will not be mentorship or any consultancy. Will be really a time to get to know each other, to connect with each other, to listen you guys. What do you have to share? What excites you? What do you expect from your journey with Soil Food Web School? And this will be in celebration of the World Earth Day. So we could not imagine a better way than the house party. You guys sent us amazing feedback from the last one. So we brought it back to you guys. Thank you so much. Oh, we're going to have 15 team breakout rooms. And it'll be like the last time. Last time, Nick, I don't know if you remember, we have rooms that stayed there for 3 hours in a beautiful conversation. So
They are great, so full of energy, and anyone who wants to get involved, please come along. It is a great session. You can pop in and out of the rooms, join into the chat, start conversations, and find out so much and learn so much from other amazing people in our community. So thank you, Carla, for that. So without further ado, we're going to move on to the main part of tonight, where Didi is going to give us a presentation about soil health and the importance of soil global ecology, and that's going to be about 45 minutes or so, and then we're going to have a break for 4 minutes. And then we've got at least, we're hoping, 45 minutes of Q&A. So that's what we're going to do. I hope you're all going to buckle in and enjoy this amazing presentation from Didi. I think it's over to you now, Didi.
Great. Thanks so much, Nick and Carla. Good to be here with you today and with all of you. It's fun to see where everyone's joining from. And nice to be here also with Alice and Sammy and Luke, who have been a good team for me when I've been teaching through the Soil Food Web School, which I always enjoy. And we're going to go right to the slides here. Give me a moment to get it set up right. Okay. Great. Okay, so as you heard, we're talking about soil health and its importance to global ecology, which is enormous. And I'm going to build toward that centerpiece by telling you my story of how I got to be in this work, which is quite an interesting, odd journey. It was not direct at all, but it's really the heart of this presentation is how do we evolve our understanding through asking better questions? And I'd like actually to start by asking all of you to put in the chat, not in the Q&A, but in the chat, what is the big question that brought you here today? Because we all have these questions kind of working in the background. Sometimes we're conscious of them, sometimes we are not. But if we're lucky, those questions and themes that we're interested in form what one of my mentors, Carol Sanford, called a long thought process that goes through life with us, and our thinking evolves, our questions evolve. We ask better and better questions over time, and that's how we learn. So if you can put into the chat what big question or questions brought you here to this webinar today. And that the way that I work, and now that I'm looking back over life, seeing that I'm continually trying to refine and evolve those questions I'm asking. And I'm also trying to involve more and more people in asking good questions, evolving those questions, and also answering those questions. Because each time we start to answer a question, the next question becomes something deeper. If you're not satisfied with like, oh, now I've found the answer, and this is going to be the same answer I give for the rest of my life because this is true. And that's a dangerous game to settle on an answer. It's much more fun and much more likely to succeed if you always assume that your answer is only partial. It's not really the whole thing. So I'm going to start this story when I was from age about 30 to 40. I was working as an acupuncturist, holistic healthcare provider, nutritional counselor, working with patients in a very small town in Vermont. I had my own practice and also had a group practice around me. And one of the key things I really did was working with people on nutrition and thinking about eating nutrient-dense foods and pasture-raised animal products and wild foods, etc. I was invited to host a table at something called Sunfest that was an expo, like different companies showcasing their products, etc. And the lower floor was sustainable living, right, and alternative energy, etc. the upper floor was all alternative health and holistic health. And the night before that, I thought, that's so interesting. Like, how did they pick those two topics? So in 2006, my question that night was, how are sustainable living and alternative medicine connected? Or, alternative energy and alternative medicine. What do those two have to do with each other? At this point, it seems like a little bit more obvious to me, but at that point, they were both topics that not very many people were talking about. And I started writing the night before, and I spent much of the night writing up this ecological medicine manifesto that I then handed out to people, hundreds of people at this expo, and this became the the center of an exploration that took me another 10 years or so of writing a book that ended up becoming called The Ecology of Care. And I won't go through every piece of this, but just it's intriguing to me reading back that some of the stuff that has cycled all the way back around to being really important questions now. So if we think about ecological medicine, or sometimes I called it sustainable medicine, but I think my original title was correct, that ecological medicine knows we're part of a complete system that is perfectly balanced, interdependent, and constantly changing, that our bodies are a microsystem that are reflective of and included within the whole. It teaches that the health of the environment is intricately linked to human health, and caring for the environment is part of caring for ourselves. Connection with nature is essential. Disconnection from nature is the beginning of the end. Ecological medicine sees the body as its own ecosystem, that all parts of a system are linked and collaborative, looks for patterns, not individually occurring symptoms. It gathers information from the whole system, respects the rights of all, and I would now say aspects of the system, not parts, to coexist and collaborate, does not deplete resources, uses local medicines, does not exploit the natural world for the purposes of humans, does not add to the toxic waste stream and create further illness, works within the patterns of nature, not against them. Ecological medicine is slow medicine. It allows time for deep listening and understanding, and time for deep and lasting cures. So over the next 9 years, that became this book. It took much, much longer to write than I thought. And writing this book took me on a journey that changed my life as I tried to research this and try to understand all of that. So I kind of thought this was all true, but I didn't really know why and how. And it took me to places way beyond that as well. So in 2007, kind of my starting point, because I shifted toward this idea of sustainable. I thought, oh, that's a really good word. It was a very new word in those days. How do we need to practice medicine in order for it to be sustainable in the face of peak oil and economic collapse? I discovered the transition town movement, and I actually got a very small grant to go and give talks at transition town movements about this, because they were looking at transportation and food production, et cetera, but they weren't looking at healthcare. 2009, as I started writing more about this, I realized that there were parallels between the history of agriculture and the history of medicine over the last 100 years, that they both had gone from being something quite holistic and systemic to something that had become industrialized and specialized and monoculture, that you're either a cardiologist or you're a gastroenterologist. Either you're growing corn or you're growing beef. But there were two other really big themes that came out as I was looking at this. That one is like a sterile paradigm of care for people and land, where we kill off whatever doesn't fit. So we have antibiotics and antimicrobials and pesticides and herbicides and dewormers, etc., right? And we separate things from their context and meaning. And we do that in both medicine and in agriculture. Everything has to be sterile and clean and kind of laboratory based. It's also very connected to big profit. It becomes corporatized and best management practices that fit, everyone's supposed to do the same thing. And that is very, very different from a fertile paradigm of care for people and places where we respect and collaborate with the quiet work of intelligent self-organizing systems. We're learning right along with it. There is no best management practice because we're continually testing and seeing, trying things out, trying to use all of our senses to understand what's going on, evolving our questions like we talked about earlier. Very different paradigm of care. And so the big question behind the book was, how do we shift from this place where we've gotten to this very industrialized corporate system back to something that's more fertile, that's not interested in killing things off, that's interested in working with all aspects of the system? 2011, a new question happened, because in 2011, where I thought that climate change was just something that was happening in other parts of the world, we had Hurricane Irene, or Tropical Storm Irene, came through Vermont in northeastern United States where I live, and it took out hundreds of miles of roads, hundreds of bridges, and I suddenly realized that climate was going to be real where I was. It wasn't just about things getting warmer. It was about water. I heard Bill McKibben speak and started thinking about how does climate change influence water and rain and drought and flooding, etc. I also became really interested in this question of why did it flood here? And as I was driving around, and like 70% of Vermont is dirt roads, like this one. So most of my neighborhood looks more like this than a highway. And all these roads were built along streams that used to be deer paths, and then they were footpaths, and then they were horse paths. But then when the automobile and cars were invented, you couldn't just cut through the woods anymore, right? So we have all these roads along streams, and when those streams flood, they take the roads out. So everywhere I went, I started looking at the streams and thinking, what's going to happen here the next time it rains? What's going to happen the next time it floods? Should I be living here or should I move somewhere? I always used to want to live next to a river. Now I thought maybe it'd be better to live next to a lake. I also started noticing that, so interesting, like the road broke, but the woods didn't break. The water took, this eroded, this did not erode. What's the difference there? And I became fascinated with flooding and soil health and biology and kind of the whole watershed function. At the same time, I was still very continuing this thing about climate change, and started realizing, okay, I guess I've got to add climate change into this book, into the stuff that I'm thinking about. I can't just assume someone else is going to deal with that. So I started looking into how does climate change impact human health and ecosystems, and writing about that as part of this. And also, what is the carbon footprint of healthcare, and how do we lower that to stop climate change? So I started looking into carbon calculators, and it turns out healthcare is like 17% of the GDP in the United States is on healthcare. And so you could say, in many ways, with all of the industry and manufacturing, et cetera, that 17% of our climate change, you could say, it has to do with the way we practice healthcare. But there was another question, because my book already had this big theme of cows. which if you read it, you'll see why. Looking at the history of cows and the history of both agriculture and medicine is very linked. I also was a lot of my farmers are dairy farmers and beef farmers doing beautiful, beautiful grass-fed products. And so I started asking, how do I deal with the fact that cows are considered bad for the climate, but grass-fed meat and dairy are good for my patients' health? And I love cows. So I was in the bookstore doing some research on climate, and I came across this book by Judith Schwartz, who's become a good friend of mine. She also lives in Vermont, and it was called Cows Save the Planet and Other Improbable Ways of Restoring Soil to Heal the Earth, Unmaking the Deserts, Rethinking Climate Change, Bringing Back Biodiversity, and Restoring Nutrients to Our Food. And I got about halfway through this book and I said, oh, wow. This is a game changer, both for how I'm going to write my book, because it brings all this stuff that seemed very disparate all together. And this is what I want to do when I grow up. like I was just so fascinated with the idea of soil carbon and holistic management, etc. Absolutely fascinated. And so I called up a friend of mine who worked in climate and said, who do you know who's doing this work? And she introduced me to a number of people, some of whom lived actually right in my town. A lot of the pioneers in this. I happen to be in an interesting area. And I went to the climate march in New York City, and I was rah-rah. I was 100%, like the advocate. Got some friends involved, invest in soil, cows save the planet. The back of my shirt said microbes rule. My old roommate had one saying pro cow. And meanwhile, but we got a lot of flack for this because at the climate march, there was a lot of people who were very anti-cow, right? There was a lot of anti-cow signs, etc. So it's an interesting time. But these pictures remind me of how, when you get really excited about something, you just can't wait to talk to people, even if it's an argument. So around that same time, I was like, okay, I want to do this, I want to shift to working in this way. How do I get involved in this soil carbon thing and in holistic management when I'm not a farmer, I'm not a rancher, I'm not a scientist, I didn't go to ag school. And so I just started attending conferences. And one of the first conferences I attended, Elaine Ingham was the keynote and also had a series of workshops. And I got to hear the whole Soil Food Web story. And that was very helpful to me, thinking about soil aggregates, thinking about what is going on with soil. And I also met someone named Peter Donovan, who had an organization called the Soil Carbon Coalition. And Peter had sold all his belongings and bought a school bus and was traveling all around North America, measuring soil carbon, water infiltration, bulk density, or the fluffiness of soil, and biodiversity, and holding workshops. And he had a workshop at this same conference that I was at with Elaine. And he gave a talk called The 7 Generations of Sunlight that was so inspiring to me, going all the way from sunlight down through the carbon cycle and the water cycle, and all the way down to human intelligence and how we ourselves influence how much sunlight hits the earth, what happens to it, how much of it turns into plants versus into heat, etc. We influence all of that. And that it's our own idea, it's our own paradigm that needs to shift in order to change that. And it's really about how we decide, how we think, what we believe. So I asked Peter if I could learn to do this monitoring with him, because I thought this is a way I could get involved. And he was pretty much working solo. And so I started flying out, like once a month, I'd fly out and meet him wherever he was. And help to do the monitoring and also teach the workshops and doing the water infiltration testing. And then typically I was the one doing water infiltration with a group of people, and he was doing soil carbon monitoring. And but I found, which worked great for me because I'm a water person, and the conversation about why is water infiltrating here versus there was fascinating. And we were everywhere from way northern Alberta, Canada, to California, to New Mexico, all over North America. Obviously, I had to, well, let's see. One of the questions that was kind of following us around wasn't so much my question, but that we had to address a lot is carbon good or bad? Right? Because carbon, this was the kind of dominant narrative is, we want a low carbon thing. We want zero carbon. We want net zero, et cetera. Carbon is a bad thing, right? It's a chemical, it's a thing, it's a chemical element, it's a pollutant, and it's the cause of climate change. And what I was trying to start advocating for is that carbon is not a thing. Carbon is life and life's remnants above and below ground, right? And even fossil fuels came from life. So this is part of what I was teaching, is that plants sip CO2 from the air, they add water, and they use solar energy to turn that carbon into life. CO2 is carbon dioxide. Some of that carbon they turn into the photosynthates, the carbohydrates that they use to make themselves. This is a little plant root here. And much of it, up to 50 or 60% of it, they feed out into the soil life around them. And if you've studied with Elaine, you know about this, these root exudates. And that is food that creates this whole underground world full of life. And that underground life builds these soil aggregates. And we'll talk a lot in a moment about soil aggregates and the soil sponge. So, and then above ground though, it's also that carbon is turning into life. So it's turning into the grasses, it's turning into the cows, it's turning into the earthworms, it's turning into everything that's eating above ground and everything that's eating below ground. And then of course that life creates more life. Some of that carbon comes back out after digestion as CO2, but it comes out, look where it comes out of the cow's mouth, comes out right next to the plants, and the plants, the stomata on the underside of the leaves are taking up that carbon right where it's available to them from the mouth of the animal or from the respiration of the microbes underground. So at the same time that my question was, how do I change my career so I can work on this full time? Because it was getting kind of expensive. And while also learning what I need to learn so that I can teach others. And so I wrote, I thought I would write one $50,000 grant to write curriculum. It ended up being like 10 $5,000 grants because I had never tried to raise money before. But I spent the next few years while I was traveling and also writing up a teacher's manual that was aligned with educational standards, is aligned with educational standards, called Understanding Soil Health and Watershed Function. It's available as a free download, and it's actually, it's being used in over 90 countries now. It's been downloaded for use thousands of times. It was in part funded by the USDA Climate Hubs, our Department of Agriculture. But many other people donated, and it's a really interesting document and was a really fun way to start really clarifying and crystallizing what I knew. And I would say the big question of that book is, how does soil aggregate structure influence flooding, erosion, and drought? So this is a soil aggregate. This is little clumps of sand, silt, and clay that have been glued together. This is a photograph by Phil Lee, an Australian soil scientist. So they've been glued together by the snot, slimes, and glues of life. And then they are also tied together with these fungal hyphae, the mycorrhizae. And you can see they're also somewhat tied together by the little plant roots. And those bioslimes, right, they're like any of those slimy things in life, are both water resistant. They're water resistant, so they don't fall apart when they're wet. So if you think about trying to clean dried egg off of your plate, if you like scrambled an egg and you left the raw egg in the bowl and you went to work and came back, it's very water resistant. It's hard to wash it off, right? So those slimy things become water resistant. So when water moves through here, it does not break these apart. But by creating these aggregates, you're also creating this amazing space here underground. And that space leaves room for water to come into the soil, to infiltrate into the soil. So you have this amazing combination of things. It's water resistant and it's water accepting. And that is magic. That is what makes life on land possible, is because of having those things together. So I was trying to develop curriculum with a bunch of high school students who some friends and teachers who I had gotten in touch with allowed me to come and test things out with the students. And somewhere along the way, when I was traveling with Peter, I had heard him say that unhealthy soil is kind of like flour and healthy soil is more like bread. And I thought, well, that would be a nice way to show the difference between aggregated soil and unaggregated soil. So we brought in some flour and bread and we tried it out. And one of the students made a video of it to submit to a video contest. And I brought that video. At this point, I had started, the Ecology of Care had been published, and I had started speaking at conferences. And I brought that video to a conference and showed it. And there was a scientist, well, here, let's see. So yeah, this is, so there's the flour versus bread, here you can see. And then you can also do it this way, where you can put a clump of soil into a little screen and some water. And if it's aggregated soil, remember I was saying about like it's sticky and it holds it together, the water will stay nice and clear. Remember, this is soil, not compost. Those of you who've studied compost always have questions about the color here, but we're talking about soil that's mineral particles held together by those biological slimes. Over here, that's unaggregated soil, it falls apart, right? So when after a big rain, the water's going to be clear here when you have aggregated soil in the farms around or surrounding it. But the rivers are going to run brown after a flood event or after a big rain if the soil is unaggregated. So I had a student who brought this flour versus bread thing to a conference, and also this, we were doing work with like rainfall simulators, and you can see here how when you have unaggregated soil, all of the water runs off, nothing soaks in. And when you have aggregated healthy soil and you're using all of the soil health principles, so not tilling, not using excess nitrogen fertilizers, having biodiversity, having living plant cover and dead plant cover, so plant litter, and eliminating as much as possible the use of all of the pesticides and biocides. Now over here, same soil type, different result, right? Different management. All the water has soaked in, nothing has run off. Total difference in how the water moves there. So at this conference that my student was presenting this, we were presenting this curriculum, there was somebody in the audience named Walter Jena, who's a scientist from Australia. And I don't know if any of you know who made this. I just found this online. I think it's very funny, the Walter cycle instead of the water cycle. But Walter Jena was giving a talk about hydrological cooling through the water cycle, global cooling through the water cycle. And And he was using this term, the soil sponge, as the foundation of this hydrological climate cooling. And right after his talk, we ran up to each other because he said, hey, that flour and bread is a great example of showing the soil sponge. And I said, hey, the soil sponge is a great word for what I'm trying to show of this thing, how the soil aggregates don't break down in water, but they accept water. Because of course, if a kitchen sponge fell apart every time you put it in the dish tub, it wouldn't work very well, right? Or if it didn't hold water, it also wouldn't work. So I loved his term. He loved the demonstration. We started talking. Turned out it was the first time he was in the States. He wanted to see some other things. So I popped him in my car and took him off to Vermont for 3 days, turned on my tape recorder, and the rest is history. We became fast friends, and we started holding conferences and traveling and teaching together, also still working with Peter Donovan. So both of them became close colleagues. We traveled and taught together, and kept coming up with more and more different interesting ways to explain this as we were developing these conferences, etc. So through working with Walter, I started to understand that it wasn't just about flooding and drought and water quality. And my question it shifted from originally, how does climate influence water, right? And how does climate influence health? And my question started to shift a little bit more to how does water, or how do water and life influence the climate? Very different mindset, right? And it got me out of the just thinking about CO2 as a climate driver into thinking about water as this big primary thing and CO2 as also a climate driver, but not in the same way that water is. And I'm not saying this is different than saying, oh, climate change is only about water. It's more that how we manage soils, how we manage life, how we manage the land surface, how we manage our food systems affects the way that water can cycle through. It affects the way that heat works on the land. It affects whether we have rainfall or not. And so climate change is not so much the cause of all of these symptoms of drought and flooding and wildfire and erosion, et cetera, and biodiversity crisis. It is in some ways the symptom of the fact that we have changed our land management. So it's a very different mindset. And Nick, I'm watching you. How far along are we time-wise? Oh, actually, I can just look at my clock here. Let's see. Okay.
You're
Yeah.
fine. Yep.
Okay.
We're okay, Didi. We're okay.
Okay, great. Thanks. So everything that I'm saying here today, there's hours and hours and hours of material on this, and I'm hoping that many of you who haven't already taken a course with me will take a course so that we can unpack all of this in a lot more detail, but we will also have an hour today to unpack some of it. So just briefly, some of what we're talking about when we talk about how weather and climate are influenced through land management, and how you can, how life changes the weather through life's processes. Diverse plants and other species create those soil aggregates that form a soil sponge. That soil sponge soaks up rain, prevents floods and drought. More plants can grow, and the green season lengthens in certain parts of the world. The additional water and vegetation provides more cooling through transpiration and latent heat fluxes. And transpiration is like plants sweating, and as plants evaporate water or transpire, that water changes from something that is sensible, they use heat, and that heat changes from sensible heat that you can feel and that's making the air or the plant leaf hot into latent heat. And that's called a latent heat flux. And that heat does not warm things up again until that water recondenses from a gas back into a liquid, which typically happens further away from the surface, higher up in the atmosphere, closer to space where the heat can get released back out to space. So it actually is a driver, it's a pump like an air conditioner that's pulling heat from down near where we are and releasing it up higher up in the atmosphere. Same way that an air conditioner works, but an air conditioner is taking that heat from inside your house and pumping it out into the street where people who are unhoused are getting even hotter, right? Or people who are out walking on the street are feeling that hot air blowing on them. So it's only helping the houses. It's not helping the whole place. So Walter proposed, and I've worked with other big scientists, John Norman, who actually wrote the book on environmental biophysics, that back when he was calculating a 5% increase in vegetation could reverse the warming that we've already seen. We would have to double that now, 10%. If we look at farmland, I think it would be a 40% increase in transpiration, could reverse the cooling that we've already seen, hypothetically, just through transpiration, not through, then you have the additional benefit of the soil carbon, you have the additional benefit of the shading, all kinds of other things that we'll talk about in a moment. But transpiration is a very, very powerful cooling effect, both locally and regionally and potentially globally. We don't really know, but it makes a lot of sense. Okay, so, and we could talk about how do you get 40% more transpiration on farmland? Well, cover crops, diversity, different leaf structures, agroforestry, having more trees and pastures, having less bare ground, all of that also creates more sponge structure, right? Because all of those photosynthesizing plants that are transpiring, they're sending those root exudates down to create the soil structure. So it's a win-win-win. It keeps going around in a beneficial cycle. Okay, because there is soil moisture in that sponge and because there is shade from the vegetation, it means that the surface stays cooler and the surface is radiating less heat back into the air, dramatically less heat back into the air. And then when you have a cooler, greener landscape, these low pressure zones will form there. And that is like, that is what creates what's called the biotic pump. Those of you who might have heard my recent webinar with Anastasia Makarieva, that pulls in moist air from the coast and helps to spread out so you don't have big hurricanes on the coast. You have nice, even rainfall across the continent, because typically now we have lots of precipitation near the coast where the water is always evaporating from the oceans, and we have drought inland. Next thing that happens, or these are all happening at once, so it's not really next, it's hard to talk about, easier to draw, that life in the air, so everything from pollen to volatile organic compounds to bacteria that live in the air but are released from plants, those become nuclei that can condense that gas, that water vapor, back into cloud droplets and then into rain or snow or ice crystals that are heavy enough to fall back to the land. So you have to have life below ground to have clouds and rain forming above ground. It also takes those humid hazes when you don't have enough life there, you just have dust in the air and exhaust fumes in the air. You have a lot of humidity and toxic pollutants there. But if you have that life, those plants that are cleaning the air and providing those nuclei for clouds to form and for rain to fall, then the humid hazes can disperse and something called the nighttime radiation window reopens. So it means that you have nice, clear, clean skies at night, and you can see the stars, and the heat that has collected in the cement and the stones and the soil, etc., and in your car can be released back out to space at night. So you have cooler nighttime temperatures. That also allows dew to form with the water vapor that's still in the air, and that is a huge additional source of moisture for plants. So one of the biggest changes in our climate, our nighttime temperatures have been increasing. So this being able to reopen the nighttime radiation window is a really key thing. And we need that life on the ground to create those nuclei that can condense that water to make the clouds so that there's space in between the clouds, or after the clouds have rained out like they do in tropical climates, at 3 or 4 in the afternoon, you have a nice clear skies at night. So we need that in order to lower those nighttime temperatures. So when the sun comes back out in the morning, it's starting with a nice cool palette. It's just bringing it back up to a more neutral temperature. It's not these heat wave things where it never cools off at night and then it's even hotter in the morning. Okay, so then when you do get rain, the sponge soaks in the water and slowly releases it back into the plants so the plants can keep transpiring. With more moisture in the ground, more plants can grow for longer, which grows a deeper sponge. And you repeat and you repeat and you rinse and you repeat for thousands of years. And that's how we grow amazing ecosystems that regulate their own climate. I won't go through the bad news of how we've disrupted all of this, but believe me, I think you can imagine we have disrupted this hugely through deforestation, through tillage, through monocultures, through paving over things. There's a big recent article showing that sea rise there's been more sea rise from soils and land not accepting rainfall than there has been from melting of ice sheets and glaciers. So unbelievable. That's what Michael Kravchuk has actually been saying that for a long time, but it just came out in a big study. They're talking about those air temperature differences. The air above a green transpiring landscape is cooler than bare soil by a mean difference of 5.3 degrees Celsius, almost 10 degrees Fahrenheit. And if you compare green transpiring landscape to pavement, almost 12 degrees Celsius cooler, or 21 degrees Fahrenheit cooler than pavement. Huge, huge difference in air temperature. But you only get that if you have a soil sponge, right? Because it's a green transpiring landscape. Whenever plants are photosynthesizing, they need water. And when they photosynthesize, they transpire to release some of that water as it moves through them. So they need water at the root zone. So you need plants to make a soil sponge. You need a soil sponge to make plants. It's all part of the same system. The Guardian recently had a really fascinating study that they made reference to. This is by Kumar and al. Looking at the average cooling effect of air temperature compared to nearby city streets. I'm not sure if it was London, but it was in the UK. And again, here, these are mostly in Celsius, but I've given a little clue in terms of Fahrenheit if you're in the States. This is the range. So look at some of these, like a green wall might be 18 degrees cooler than nearby city streets. But I'm fascinated by these top 3 because botanical gardens, wetlands, and rain gardens, actually green walls, you could say too, for the most part, if they're very intentional green walls, they always have water at their root zone. Botanical gardens are rare specimens. Nobody wants them to die. So they're always getting watered. Wetlands have water at the root zone just by nature. Rain gardens are very likely to have enough water. Green walls often have an irrigation system. So you can see how the coolest ones have that water at the root zone. And in a farming system, a ranching system, or nature, that water at the root zone is there because of the soil sponge. So it's that soil aggregate formation that is fed by photosynthesis by healthy plants. Okay, by 2017, I was really focused on, I started getting annoyed, even though I started off so excited as soil carbon. Everybody was talking about soil carbon as this drawdown thing. And now everybody was so excited by that, they were trying to figure out how to monetize it. And it was back to this kind of thing mind and this extractive thing and this profit and Wall Street. And I was like, oh, geez, like, what have we done here? You know? So my new question was like, how do we set up conditions in policy, farming, and land management so that people can focus on improving soil structure and function, or the soil sponge, so that it can have this amazing influence on everything? And so now, let's see here. I wanna show you this spread versus flower, because what started as something just talking about erosion became something that I could use to talk about all of that. And I've talked about it at the UN and on Wall Street, which I probably shouldn't have done, and in kindergarten classrooms and farmers and ranchers conferences all over the world. And this is such a great thing to do at your dinner party. It's a great way to show how soil works. So remember, the flower is unaggregated, unhealthy, heavily tilled, heavily chemical soil. And what's happening when it rains there? It's running off, it's eroding, it's flooding, landslides, etc. It's dry underneath. There's nothing there for the plants. So we're not getting that transpiration. We're not getting that cooling, right? Also, it's more of a wildfire risk, which has become my question again this year. If leaves and branches fall down there, or if trees are growing in this landscape, they're dry, they're becoming brittle, they're becoming flammable. They don't have the fungal communities to decompose them. We've got water quality issues here. Before we put the water on it, if we've taken this plate and blown on it, we've got horrible, horrible air quality issues. In Kansas, just this month, there was a dust storm that was as bad as the ones in the 1930s. There were many, many people died in accidents because they couldn't see that right in front of them, like 70 cars piling up with big tractor trailers. Just incredibly bad, and just huge soil loss. So we have soil loss through water erosion and soil loss through wind erosion. The chemicals that are fueling this soil degradation are now all going into the water. And so then we have problems in both the lakes and streams and rivers and the ocean. And then we're not, we're not growing plants here because there's no water at the root zone. So what is the difference between flour and bread? Is biology, right? So you add biology and suddenly you have structural integrity and functional integrity. You take this out in the wind and you blow on it, it's going to stay right where it is. And if you then take that same cup and you rain on it, or you do a water infiltration test, something really, really different happens. The water is all soaking in. It has those spaces that we saw, that sacred space underground to soak in. It's going down, down deep. Of course, here we have a plate, but in reality, this would go much deeper than this. It's going down, down, down for the roots. Nothing is eroding. There's no flooding. You're protected against drought because it's protected down there against evaporation down deep. I can typically put 9 or 10 times as much water on here before we even see that water again. And the rapidity in reality of how quickly this water will infiltrate, an inch of water in a landscape like this might infiltrate in 10 to 30 seconds. Over here, it could be 4 hours. So when you think of an inch of rain falling and the flood risk, and also, how long you're going to hold on to that water, totally different. Now we're starting to see the water again, but what are we seeing it as? This is not a river. This is wells and springs. This is like clean mineral spring water that is now available below ground. It's going to start popping up. It's going to refill our wells. It's there for groundwater. Maybe eventually it's going to trickle down into that long-term savings of the aquifers, but it's mineralized, it's detoxified, it's gone through a big carbon filter, it's gone through all these life processes. So it's beautiful, clean, healthy water that is super good for everything that needs water, which is all of life. Okay, so do that at your dinner party. I think we've talked about most of this, but one thing is, when that soil blows away and it lands on glaciers, we get faster snow melt, we get less albedo, less cooling, and so we don't have stream flow down into the valleys, and that's part of that drought is having that soil blow away. What we haven't talked a lot about today, but we can get into more, and you will if you're in the Soil Food Web School, is how that structure makes it easier for plant roots to grow and for fungi to explore. And there's so much more surface area exposed for the microbes to access the nutrients. Also, the mycorrhizal fungi can access water films here during times of drought. There's always going to be some water there that the plants can't access, but the fungi can. But in this case, the nutrient integrity of the plant improves, and this improves the health of all of life. There's also things where the plant tissues are less likely to become diseased. They're less likely to freeze because they have more nutrients in there. They have a higher Brix. They have higher minerals in the liquid inside of the plant cells. This is also like a big insulation. It's like a big sweater, a big parka, a big, the fluffy insulation you have in your house walls. So it regulates the ground temperature, better for crops, better for life underground, better habitat for all the life under there. And as we saw earlier, all the stuff around flood, drought, fire, and kickstarting the water cycle, yes, the carbon cycle, and climate regulation on land.
Didi, we're running out of time a little bit, unfortunately, because we could go on forever.
I know we could. Okay, I think
amazing.
I think I got let's do 2 more minutes if that works.
Brilliant. Let's do it. Great. Absolutely. Yeah. Let's do it. Please.
Mostly just a set of sort of how the questions evolve from there. 2018, Walter and I tackled this question, which we've now returned to. Can we rehydrate California? Let's have a big audacious goal. And we went on a big speaking tour. And now with the fires in LA, that's been revived, and we're meeting regularly online. 2019, how do we create new conditions in our cultures and relationships and laws and work so that plants and life abound, soil function and structure improves, so all of life can thrive and do its work? The videos from our conferences made their way to India, and there are now 1 million farmers who have changed the way that they're farming, in part because they're starting to understand that water might be accessible even when it's not obvious. So they developed something called pre-monsoon dry sowing, where they're able to get crops year round. Look at the percent of change of the farmer's income here. It's changing smallholder farmers' incomes and the amount of food, and also the nutrient integrity of the food. We'll shift through that. 2020, COVID happens, shut down. How do we create a deep community of practice online? We've figured out ways to do that. We have our land and leadership development community. And feel free to ask more questions about that. 2025, here we are, fires in LA. How can our understanding of the soil sponge and living climate help with fire resilience? Because meanwhile, everybody's out there cutting trees and getting rid of grass and vegetation because they don't understand about a lot of this other stuff. I'm not saying that there's never a time to do that, or there aren't certain places you want to do that, but people don't understand plants, water, cooling, fire, all of that. And my last question that I'm really leading with right now is, how do we unleash these layers of intelligence in living systems that have been interfered with both in us and around us so that we can think during these challenging times that we're in? That's the end there. You can find a lot of articles here on my Substack and a lot of materials here at landandleadership.org. And really, really grateful to be invited here, giving a chance to meet with all of you. And I'm looking forward to your questions.
Didi, that was just incredible. Thank you so much. That was really, really great. And I'll tell you what, that visual with the flour and the bread, that just sums it up from a large-scale farmer like me, where structure has disappeared and we're farming sands and silts for vegetables, and we have rain events, and it
Yep.
just was exactly like the flower. It
Yep.
is exactly like the flower, and the other one
Absolutely.
with the bread is
Someone's got bread. Someone's got a found the bread emoji. I love that.
absolutely when you compact the bread and you break all that structure with tires and wheels
Yeah.
and then you do the same experiment. I mean, that was great. It's such a
Or you
great
put
video.
it, or you
So
put it
funny.
in a blender like tillage, right?
Yeah,
True,
exactly.
that's true. And we have people saying that for now on, they're always gonna have a bag of flour and bread in their bag
Absolutely.
for any place they will go. So thank you, Didi.
100%. Yeah. Yeah. And you know what? What's fun is that those materials are available almost anywhere you go. You know, if you're at a conference, just run in the kitchen, say, "Hey, have you got a?" You know?
So
Great. So, Carla, what are we
So
doing
I
next?
think this will be. I'm seeing some questions. I believe this will be on your YouTube channel, correct?
yes, the
Yes.
presentation will
So
be
people are
later
asking about the
uploaded.
presentation. So yeah, if you want to show this to your friends, etc., this will all be on YouTube. So.
Yep. So Didi, we're gonna give you a couple minutes for you to have some water, take deep breath, and for everyone to absorb the beautiful
Yes,
information you
to
shared.
infiltrate it. Yeah.
Yes,
Like
thank
bread.
you. Thank you. That's awesome. So we're gonna share a quick video with you all and while Didi take a deep breath, and we're gonna get back for the Q&A. Oh, it's not running on my end. Can you see? Nick, do you want to try share your screen? Because the video is not showing up for me. I'm sorry.
Nothing on me either, I'm afraid.
Sammy, can you help us on this?
Yeah, let me share my screen.
Thank you.
Just give me a moment, please.
Everyone, Sammy is our wizard in the background, so round of applause for Sammy, always helping
Absolutely.
us to put those webinars together.
Sammy's always coming to the rescue when we have these little glitches.
Well, I may try to come to the rescue. It's not always guaranteed. Is my screen sharing?
Yes,
Yeah.
I see Anja.
My journey into the realm of soil microbiology started with the desire to provide good and nutritious food for me and my family.
I see food as being fundamental, and food comes from soil.
And if we want to be able to continue to feed our population, we must change the way we farm.
Even in the organic world, we're forcing ourselves to alter the soils, and we're not working with the microbes and working with nature.
One day I was listening to a podcast where Dr. Lane Ingham was talking about the soil food web, and it just blew my mind.
I was just taking copious notes. My mind was just blown with all of the connections that were coming to light for me.
The course was very well organized, professionally produced, and both the video courses and supporting written materials I thought to be very thorough.
They bring in various experts in webinars, summits, and educators on the school.
Just being able to use the forum, there's always things going on and people to identify this organism or that organism.
Having a mentor to support me has just made me learn so much more than just going through the theory.
And I'm very, very happy that I am able to see what is in the soil and what I can do to improve.
So many lands are waiting to be restored, so you won't have a deficiency of projects.
I look forward to improving the soil and offering more advice in the future and growing my business, all thanks to the Dr. Lane Soil Food Web course.
The Soil Food Web School has changed my life, and it might as well change yours.
Spring is in the air, and there's never been a better time to launch your career in soil regeneration than right now. This April, we're making the Springboard 2025 offer available for just $2,499. With the Springboard 2025 offer, you can register for the Soil Food Web Foundation courses for just $2,499. saving over $2,500 off the regular price of $5,000. You'll also get 2 free bonus courses, the Introduction to Permaculture and the Soil Sponge Workshop, worth $599. The total value of this bundle is $5,599, but you'll only pay $2,499, saving you $3,100. That's over 50% off. There are only 60 places available in the 2025 Springboard registration cycle, so please don't delay. The Soil Food Web School offers a 100% money-back guarantee, so if you're not completely satisfied, you can get a full refund in the first 30 days, so long as you've watched 32 lectures or less of the foundation courses, where they cover all the science and application methods behind the soil food web approach. This is a series of 63 online lectures, each followed by a quiz. You can log in at any time, watch a lecture as many times as you like, prepare your notes, and then take the multiple choice quiz. Each lecture is approximately 45 minutes in length, and we recommend that you dedicate around 150 hours to completing the foundation courses. You get to download all the lecture slides and the FC course manual. You also get access to the FC forum, where you can ask questions that Dr. Elaine's team will answer for you. The Introduction to Permaculture is an 18-lecture course that covers a wide array of permaculture principles and themes, delivered by Graham Bell, previous chair of Permaculture Scotland and longest-serving permaculture teacher in the UK with 31 years' experience teaching on 6 continents. Permaculture is a regenerative design approach that can be applied to just about anything, from water management, growing systems, dwellings, and much more. The Soil Sponge Workshop is delivered by educator and author Didi Pershouse. This 5-session course is all about regenerating the soil sponge for flood, drought, and wildfire resilience. It builds on the successes of innovative land managers around the world who are saving huge sums in damages from extreme weather events and crop diseases, while restoring the dignity and profitability of farming. Didi teaches participatory workshops, both in person and online, helping to show the nested relationships between soil health, human health, water cycles, and climate resiliency. Financing options are now available so you can pay at your own pace with a firm. And join the soil revolution today.
Thank you, Sammy.
Fantastic. Great. Thank you, Sammy, for that. That got us out of a bit of a muddle, didn't it, Carla?
Yeah, I'm holding my tears here, Nick. So many familiar faces in the video, and it's rewarding to see how much they are advancing through the courses and how they're thriving, and they are not shying away. So, and Didi's course, I have to say, I was in the first group that took her classes, and literally changed your whole view in so many topics, connecting such a deep level with Elaine courses. It's not just because she's here. I said that in other webinars. That's a course that's a must for sure.
Absolutely. Absolutely. So are you going to take the first question, Carla, and I'll follow in after you?
Yes. So the first question is from Anthony. Thank you, Anthony. How do we increase the microbial communities within the soil ecosystems? And also, how can we increase the beneficial insects within these ecosystems that we are trying to improve? Who wants to start answering?
I will start, but I think that that you will both add something to that as well. I would say that the key thing here is to have a diversity of crops, or whatever you're planting, whether it's a crops or a pasture or your own garden, etc., or your lawn even, that you want to have plant diversity. They're now saying that they've found that 4 plant families and 16 species at least, is there something that happens that really, really changes the community dynamics of the microbes. I just heard Dan Kittredge talking about yesterday that the biggest influence on nutrient density of food is the amount of life in the soil, just the amount of life. So plant diversity is huge for the microbial communities in the soil ecosystem, but it's also huge for increasing beneficial insects. So what we're seeing in India, and also from the work of Jonathan Lundgren at Ecdisis, is that there are like 1,700 beneficial insects for every one pest. And if you spray pesticides, if you spray insecticides, it kills all of the beneficials and the pests. And then who has food first? The pests, because they're the vegetarians, right? The carnivores or omnivorous insects are dead and they don't have any food because all the other insects are dead. So it's really about increasing diversity and not using insecticides. That is the best way to do that. But I'm guessing that you have some more compost related answers or something else. So looking forward to hearing it.
I think if I go, Carla,
Go ahead.
For me, you're right, Didi. It's about the amount of different species you have and diversity. And I'm certainly here on the farm, and what I've learned with Dr. Elaine and even Nicole Masters is about the diversity element of what we're trying to do and how that comes through to the rest of the farming, the farm itself, because we're increasing our soil succession, so we're getting more fungi back into our soils and more protozoa, so we're getting more life back into these devastated soils. And then we're seeing now through a pan-species specialist, so someone who's sweeping our fields and checking the number of invertebrates we're getting in our hedgerows and also just generally in our fields. And we're seeing far more different species, more numbers. Now, the number element could be because of the season, but in terms of the diversity, we've seen a vast improvement. And this is just extraordinary for someone who unfortunately 5-6 years ago was still using insecticides. I'm sorry. I'm so sorry. I feel very bad about that. But having faith that this system works has certainly proved what we can do, certainly on our farm and other farmers I'm helping.
Yeah, and Dr. Lynn says that a lot. And if you look back in ecological studies, this diversity within the soil is intrinsically connected with the diversity you can see above the ground. So you're going to have a lot of people talking about this, including Ernest Gosh. We have a lot of videos on our YouTube channel. Here I'm going to do a nerd moment. Sorry. I still want to see a panel with Didi, Elaine, and Ernest. I think that the three of them just grasp everything we need: soil, water, and above ground. And it's beautiful to see how these three realms are so interdependent. More you understand how they're interconnected and how the biodiversity on each level interact and sustain the other, easier will be for you to increase all this microbiology back, because the system self-regulate. Like Elaine says, you have to listen to the nature, stop fighting the system, and listen to what the system is asking you for. So, and the question goes back to how do we increase the microbial communities within the soil? Here at the school, we teach you how to make biological complete compost, meaning that you're going to select the best biology for your local reality and re-inoculate the soil with that compost, or the extracts or the teas made out of this compost, and the microbes in your soil will interact with the root system, with the plants you have there, and they will start to self-regulate the system. So that's what you should be looking for, focusing on. Thermophilic compost is what we try here at the school, but there are many techniques, and like Elaine says, use your critical thinking. That's one thing that you cannot shy away from, is really asking, why are you doing this? Why are you taking this next step? And if you recover the soil, the water will go along, the diversity above the ground come along, and the insects will return to the system. So did we miss anything, Didi?
Oh, I was just going to add that one of the things that they're doing in the Andhra Pradesh project, and I think this is maybe similar to the Korean natural farming, is that in Andhra Pradesh, India, they're making biostimulants, which is different than compost, out of cow dung and cow urine that have been fermented with sugars and inoculated with forest soils, etc. And they use that both as a liquid and as a seed treatment. And what my colleague Walter Jena says is part of what's going on there is that it's actually the enzymes and hormones that are there that wake up the dormant soil biology. So there's soil biology. Sometimes we need to import, like kind of with a compost thing, right? But other times it's there and it's dormant and it needs to be woken up and start eating each other, which then releases the nutrients for the plants also. And so that's an interesting other approach is through those kind of things that involve more animal products in the making of them.
Yeah. But any biological system is dynamic, right? So if you stop to pay attention, you're going to know, okay, now is not the best time for compost. The biostimulant will do what I need. Now the compost will deliver what I want. I need the tea for the leaf coverage protection. So it's really understanding and expand your toolbox of techniques. So you're going to have the whole set and going to be able to do whatever you need to help the system. Nick, sorry, I interrupted you.
Sorry, and of course, what Didi was talking about and has had lots of experience of from her presentation is the water holding capacity of the soil and how that improves, and we've seen that increase certainly on our farm, no end from just improving the ecosystem below the ground. It's been an amazing transformation for us. Great.
Yep.
Thank you. That's a great question, Anthony. Let's move on to Paula's question. Thank you, Paula, for this one. How do we transform a typical agriculture farm to a regenerative farm, starting with amending the soil? Didi, do you want to start with that one?
Oh, that's a big question, but I think there are a number of different capabilities that need to be built there or need to be grown there. One is understanding to be able to start learning whole systems thinking. And that's part of what you'll learn in the Soil Food Web School. It's part of what you learn in my course. I recommend that people take a holistic management in terms of decision making and thinking about monitoring, et cetera, as another way of changing your mindset to thinking in a more whole systems way. And the whole systems includes the people who are involved, the community that you're in, the uniqueness of your location and soils, et cetera. The soil health principles, which are not just, there's like 3 or 4 that the USDA talks about, but really it's a growing list of what are the conditions that are needed for soil health to grow. And so some of it we've made reference to, like reducing or eliminating tillage, reducing or eliminating compaction from heavy machinery, though spongy soils are more resilient in that kind of case. Having a diversity of plants is really key, including animals in the system in some way or another, and planning to include them, whether it's just through their dung or whether it's actually having them move through the land. And that includes insects and birds, et cetera, right? It's not just about cows, even though I love cows. Reducing or eliminating all the biocides, most of the time those are making things worse, even though they seem like a very short-term gain. Figuring out a plan, not just doing it cold turkey, but figuring out a plan to get off of the fertilizers, and be careful when you're doing that. You don't want to just stop unless you have time to just take a year off from reharvesting much. I think those are some of the big soil health principles. I may be forgetting 1 or 2, but I think changing the way that you think the way that you see land is really key. Learning to monitor. I know there's another question coming up about that. I'll save my answer there for that. But learning to really monitor and see what's different. Going out with a shovel and checking out what's different under the fence line versus what's different where I've been using tillage, or what's different where the animals have been standing around versus not. So getting curious. But you can do it. You can do it. Many people have, and finding a community of people that you can ask questions to, finding mentors.
Beautiful. I would add just one little point on your beautiful lecture, Didi. Thank you. Is that if you have employees in your farm, help them change the mindset. Because you're going to do the beautiful management plan, you're going to do all the work you need to do. But if you have some of your employees that are not on the same management plan, as soon as you go away, they just might, especially in some locations, they're just gonna, they don't know what they're talking about because they don't stay here daily basis. So I'm going to do whatever I want. So if you are in a location similar to that, I would encourage you to also bring them to the process of understanding why you are doing those changes, proposing those changes, show them the microbiology under the microscope. They need to see what they're helping you to build. They need to see the water flowing, make the flour and bread test with them, show them that the change is real. So then you're going to help them to, they will help you change the system.
I would agree with all of that. And for me, mindset is the biggest thing. And you're absolutely right, Carla, about it's great having a management team that is pushing forward these great concepts and ideas to change, transform farming system. And it's wonderful. But I think I might. Can you hear me? I think
yes, we can.
Yep. Sorry, but actually transforming the guys on the farm who are actually doing it is you've got to take them on the journey with you, and I see that when we're making compost on farms, and you've got to change their mindset. You've got to try and get them to come and understand what you're doing, and you're right. Carla, that is taking everyone on that journey. And for me, I would also add that livestock have been absolutely fundamental to what we're trying to do as well. And unfortunately, we did go cold turkey. Would I do it again? No, I wouldn't do it again. But we did. And Carla's seen how we've managed to get out of it now, but we did do that, and it was a great experience. We learned a lot about ourselves and about the system, but I wouldn't recommend it. So yeah, that's anyone's got anything else to add to that question? No,
I think we
Brilliant.
covered.
Great, thank you, Paula, for that question. And the next question is from Alison. Do you want to take this one, Carla?
How can producers of food which is tasteless be persuaded to improve it? My homegrown food is so much better in flavor and quality. Alison, you just opened a Pandora box. Who wants to start?
Well, this is something I've been trying to look at since I've started on the Soil Food Web journey. I'm not sure whether I'm any closer to finding out whether I'm doing the right things or not, certainly for growing cereals. But certainly veg, I've tried the system, and through SAP testing, I'm sure there's other ways, but certainly through SAP testing, lettuces, carrots, etc., stuff you necessarily don't have to boil or steam. We've seen a large improvement in some of those minor minerals that probably are lacking from our diet currently with the foods that we're eating and growing. So I'd be interested to see what Didi has to say about this one.
So I love this question actually, and there are a few things here. One is that food that has better flavor and quality means that it has more plant secondary metabolites in it. And apologies, I have an incoming dog here who's just back from a walk. Those plant secondary metabolites, if you followed any of the work of John Kempf, they also make the food and everyone who eats the food much healthier and more resilient to disease. So what you can do is to do a shelf life test. So you take your zucchini or courgettes or your, tomatoes or your, whatever, bananas, and you put them out with some that have been grown, ones that have been grown much more conventionally and ones that have been grown in a much more living system. And you pick them on the same day and see how long they last. And if it has a lot of those plant secondary metabolites, it's going to be resistant to mold and mildew. It's also on the vine, it's going to be resistant to viruses. It's going to be resistant to beetles, all of those things. And it's going to be resistant, therefore, to rot. So it will dry up and shrivel up before it will rot. And it will last way longer before it even starts to dry up. The other thing then that goes along with that is that you start to say, hey, how much are you losing in terms of waste because of you have to get it to the market fast? And also, how much are you losing on the vine to insect pressure, et cetera? Because it's not just about what insects do you have, it's do the insects like to eat what you have. And just like us, insects like simple, pasty, white food, right? They like our 2-year-olds. They like things that don't have a lot of plant secondary metabolites. That's why we use those essential oils and secondary metabolites to create natural insecticides like cedar oil, et cetera, citronella, et cetera. So, and then the third thing you can do is you can do a taste test with chickens, chooks, right? Put out some bowls of one and bowls of the other. Which one do they go to? Then if you really want to get hardcore, then you go to the farmer's market and you buy something from every stand and you put it on the table and have people sit down and do a taste test or have a barbecue, So I think we need to remember that we have senses for a reason. Our senses are there to help us stay healthy, to be able to choose things that make sense for our bodies.
Yeah. You touched on a very good point, Didi, that normally I talk with my students and clients is that in the end of the day, the farmers are worried about the bills. The bills don't wait. Doesn't matter how much you're going to produce, the bill will be there in the end of the season. But if you can track down the cost, like you mentioned, not just the yield or the produce, but how much each treatment costs you in the end of the day is another way that the resistant form can at least give you a chance for do a small trial side by side. And another thing is that there is a lot of research going on. I'm seeing a lot of publications, peer-reviewed publications of medicine, and not just the natural medicine, the more and more the gastroenterologists are looking for human gut, and they are starting to connect with soil health. So what do I have in the soil that leads to that produce, and how that produce impacts my human gut health? So people are changing their mindset. They're seeing that everything is interconnected, which take us back to our K-12 grade biology classes. We are just one species on this planet, and everything is a huge food web. Only depends on which branch you are looking for, but everything is interconnected. So it's just logical that more healthy soil you have, more healthy food you're going to have, more gut health you're going to have. So I think that finally science is catching up and connecting all the dots And I think that pretty soon this will get to the field, but we need to be patient with the farmers because they are on this hammering layer of heavy chemical approach for many years. In the same way that we had the green revolution, now we are in the middle of the biological revolution.
And Carla and Didi, I don't know what you've just seen, but in the chat, Denny's just asked, what do you guys think to using a bricks number in terms of looking at this improvement in taste within food? What do we think to that?
I think a bricks is a general. It's useful. It's general, but it's not the same thing as our own senses. And I think it's that side by side thing. It's one thing to taste something if you're used to tasting things that are kind of like that. But like I said, I went to a party last year where I brought some grass-fed meat and somebody else was serving from the regular supermarket, and I didn't know which was which because it looked the same on the grill. I put some, and I was like so clear to me when I had two pieces on my plate which was which. So it depends what you're testing and for what reason. Nothing wrong with bricks, but I think it's just a beginning. It's kind of an opening door.
What do you think, Carla?
Yeah, I agree with Didi. I see the bricks as an indicator, like a fast check in the field. Yes, I'm getting good results. I'm on a good way. Here we go. But if you want a more in-depth analysis, how things are really changing, and if you have the time and the resource for that, go for a more in-depth analysis. But the bricks is a fast check in the field that I all up to use it.
We've just gone looking at crops last year. These are just winter wheat crops, about the same sort of time. And we saw bricks levels of about 3 and 4 from our cereal crops. And this year, because we're changing our farming system and adding compost and biology and doing all sorts of other things. And we're seeing bricks sort of 8, 9s and 10s at the moment. We've just sent some of those to be analyzed to see what the SAP is saying as well. And as you said, it's just a very fast indicator to carry around with you. I have one in my truck and I use it all the time. So yeah.
Yeah, I think that what we cannot mix is that we need that fast track checks in the field. And if I'm going to go for publication, if I'm going academic level, then is another realm of tests and studies I need to do. But rely on fast checks as a guideline, as an indicator for you in the field. And I can bet that going to be headed to the right direction.
Brilliant.
And I'll just say there's interesting work going on at the Bionutrient Food Association. I know that Dan has been on a webinar here with me in the past. He has developed a handheld meter, but they've also just been doing a very, very big study that is, I think, almost ready to publish some of the results about the variability in nutrients across different production systems.
And that's with handheld meters, did he? Yeah.
Well, no, I don't know that they're using the handhelds for that study. They have the handheld that they've been developing. Yeah, I'm not sure about that. I think that may be in a more traditional laboratory testing for different nutrients.
Okay, brilliant. Thank you very much indeed. So the next question from Randall, thank you very much indeed. How do we get a measurement of the various factors in soil affecting the soil sponge capacity?
I will jump in there because that we have a whole class on that in the soil sponge course. I will give you just a quick little. Let's see. I'm gonna have to take over the share here. Let's see if I can do that. I think I can do that for a moment. Okay. So if you go to landandleadership.org and you go to, let's see, it's a little bit hard to find it. Seed Media Project fact sheets. Measurement, observation, and monitoring this fact sheet here, how do we measure improvements in soil sponge structure and function? It's not all of the how-tos. Like a lot of these things are things you can just Google the test and you'll see what it is. But this whole thing is designed not around soil health, which is a very kind of like, what is health, right? But structure and function, those are things we can really clearly measure. And so there are both observable signs of improvement that you can see without needing to do a particular test. And then there are the actual tests themselves. So this is a kind of a long document. I'm still, adding to it when something new comes up. But again, so landandleadership.org under Seed Media Project and fact sheets. And in these fact sheets, there are lots of other articles, etc., on much of what we talked about earlier today. Sorry to take over the share there.
It's okay.
Thank you. Carla?
Yeah. Oh, let me. Okay. I think that Didi is in the house. So what else can we add to that? But I think it's important for you to understand the nuances in the area you are, how the weather changes over the seasons, so you can be better prepared for the following years. It's really important to understand the signals that nature is sending you and understand how the cover crop will interact with your cash crop, if that's the best approach for you, or what else you need to do. Do you need to do an adaptation in your irrigation system? Those little things that you need to pay closer attention to understand how they're changing the system. And measurement-wise, I think that Didi covered. It's just like follow her document. It's over there. We can all go there. And I'm all in to Google Scholar as well. If you are a school student, you can chime in and talk with your mentor. If you're not, you can use Google Scholar. There's tons of papers and publications that are going to teach you. YouTube, you're going to have, once you find the best test for you, YouTube, you're going to have tons of videos showing you how to make those measurements. But for me, the first step is to understand which factors in your location can affect your soil. Then you can start to look, otherwise you go crazy. Because what we have more in this internet is soil tests, and if you don't know what you're looking for, you're not going to be able to decide which measurement is the best for you.
Yeah, and I would absolutely echo that, Carla. And you can go down a rabbit hole when you're looking at all the different options for testing. Certainly for me, the biggest one for us was water infiltration. So that is something that we really concentrate on. And I would urge all of you, and I'm so pleased we did it, is make sure you get some baseline information. So before you start, you need to know where your journey started. However bad the number is, it doesn't matter. Let's just see where we start, and then we can move forward. And we do that with water infiltration, compaction, and just digging a hole and just looking into your soils and just getting a feel for your soil and what it's doing. So that's the sort of thing that I would recommend.
I agree, Nick, that doing a baseline is so key. And even if you only do a baseline, you could wait 5 years or 10 years before you do anything again, and you're fine because you still have that baseline. But if you don't have a baseline or you're just doing a little bit here, a little bit there, it's going to be much less satisfying.
True.
Oh, absolutely. I'm so pleased we managed to do it at the start. So yeah.
And I also Janet had a question that's related to this. On a property, is there a certain amount of soil samples that need to be taken to see what you have to work with? Should you test every so many feet? So it depends on which test you're talking about. And when we were doing the Soil Carbon Coalition, we did the water infiltration, a biodiversity hoop. This was mostly in pasture. And also bulk density, which is one of those measures that helps to see the soil sponge structure. we would do that on a transect, so that was a replicable line that we could go back to and find the same spot or very close by, however many years later. Of course, you need to document that, and Soil Carbon Coalition actually has something called the Soil Health app that if you're in part of a group project, can be very useful for keeping your measurements somewhere so that if you die or your basement is flooded or whatever, you have them stored somewhere. So we would do that on a transect, but if you're, it really depends what kind of test you're talking about and what your kind of question you have. Like Carla said, if it's an academic, for a paper, it's a different kind of information that you need and a different quality of information than if it's just giving you feedback of whether what you're doing is working. So typically if you're just testing like a classic soil test of how much of this, how much of that, people do things where they throw a rock over their shoulder different ways so that it's random. Random is different than trying to have a transect where you're trying to go back to that same spot. So again, sorry, it's not a very definitive answer, but it does depend on what question you're asking and what test you're doing.
But Didi, you're giving Elaine's favorite answer. It depends.
Yeah.
And you might want to soil test in different fields for different reasons. So you might have an area of a field that never grows anything, or the crops don't look healthier. So you might want to do a separate soil sample of that section of field and not mix it with everything else, because you might get it, whatever the problem's going on, you might get it diluted, or you might affect the other side. So I think it's all context, isn't it? Depending on the field and what you're trying to do.
Spot on. I totally agree.
So this question is an easy one. What kind of tool would I use for finding out surface temperature? There are these infrared thermometers. They cost $20 to $50, something like that. They're so easy to use. You put a battery in and you just point it at the surface and it tells you what the temperature is. You can even point it amazingly up, like in the sky. And if you point it at a cloud will be warmer than when you point it away from the cloud in just the empty sky. You're measuring the temperature of outer space. So it's amazing, like what you can measure. Then you can measure the difference between like someone wearing a black t-shirt or a white t-shirt, or a black car or a white car. And you're going to be fascinated by how different it is.
And it's funny too.
Yeah, we've just done with one of those guns that you say, Didi. We've got one, and we've done a bit of work with some wool, covering up some trees this year as a mulch, and the surface temperature was 7-8 degrees, and under the wool it was still 2 or 3 degrees. Just incredible. So I'm really fascinated by how wool or hair or whatever can affect, or it's the same as plant cover, how that can affect our soil temperatures for microbes. So those guns, I absolutely recommend people get one of those guns, because you can have so much great fun with one of those.
The other thing is just like a soil thermometer or even a meat thermometer that you can put into the soil, because there's a difference between the surface temperature and the soil temperature, and both of those will shift in slightly different ways.
Yeah, that's absolutely true.
And then, of course, there's the air temperature. A good handheld one, point and shoot, will also have an air temperature measurement. So because that's useful too, to say, oh, this soil is cooler than the air, and this is a bazillion times hotter. If we had more time, I was going to show a little video of using that on a summer day here. Incredible how different.
This looks like the theme for the next webinar, Didi.
Yes.
Okay.
Next question is from Jacqueline. I think we have time for one more. I think this has been a great overview of the why, but I'm interested also in the how. What are your ideas for practical, wide-speed application of these principles?
So I'm your why person. I'm your why person, and I'm connected into a huge network of people, many through this school of the how people. But I'm not going to answer this. I'm going to pass this on to you.
Carla, do you want to start?
Yeah, I can. So I think that let's put like in general guidelines, right? The first the how is you need to understand what you want to do and why you want to do that, right? Are you going to do this for this first round to understand the system, or you want to learn how the system is to avoid cold turkey, right, Nick?
Yeah.
So
Yeah.
you want to plan
Absolutely.
the transition. It really depends on your journey. For me, this is the first step. Understand why I want to do this. With that in mind, I'm going to sit down with, in the case, if I'm working with a client, understand what the client need. What do you need to see on this first year? Then, with your knowledge and the practices in the farm, you're going to plan, you're going to build a management plan with the farmer, and then you're going to start to do the management plan, put the dates. So to achieve application on this date, we're going to have to start making compost on X date. So you're going to be able to match those deadlines. So it's about planning. Everything's about planning. And the how, it really depends on what you want to do. So what else can we say, Nick?
Well, I would echo that, Carla. I think for me it's a timeline. So it is crucial that you make sure that you're aligned with the people that are making those decisions through money, monetizing those decisions, and also I think it's really important to make the plan achievable. Don't set your sights too high. Make these achievable targets. I think when I started on this journey, we didn't really know where we were going, and we were really trying to push as hard and as fast as we possibly could. But actually now we have more insight to what's going on, and I would do this in little bite-sized chunks. So you actually feel that you've achieved something, and then I feel it's easier to do it in a smaller way. And certainly when I'm speaking to lots of farmers, I try and urge them or guide them down that route, that we're not trying to go too hard, too fast. These principles are absolutely right, but it's how we manage that. And maybe a farmer who's got 100 hectares, I would only ask him to maybe look at 10 hectares or 20 hectares at a time, and not do what we did and go totally cold turkey and do everything in one go. So yeah, that's kind of what I would do from a purely practical point of view, and also from a cash flow point of view and a budgetary point of view. Yeah.
Yeah, and I think that the importance of these small trials allows you also to understand and adjust the management plan, right? I know that I planned X amount, but the answer was not as fast as I expected. So for the next growing season, you can remanage those management plan and adjust and optimize the plan. That's the word I'm looking for.
And that's always going to move, because we thought we were going to change it in 1 year, and we're 4 years down the road, and we're still, we're coming back out the other side, but it takes longer than you think. So 50 years of degradation and or longer, I'm sure, has taken a toll, and you're not going to do it in 1 year or even a couple of months, which many farmers I talk to think one application of a biocomplete compost extract, that's it, it's sorted, job done. But the journey's a lot longer than that.
The magic dust doesn't exist in biology.
Carla, do we have time for one more question? No, we
I think
don't.
the next question is quite important, and Didi
Okay.
asked Pascal to put that question in Q&A, so I think that we own Pascal that.
Okay, cool.
Yeah,
Okay.
thank you. I was hoping that we could just touch briefly on this. Could you please explain what monetization of carbon drawdown means?
Okay.
And we're in a time period that I made a little reference to that rather than thinking about living systems as something that are there to provide value for the whole world, right, for all life, people are starting to calculate what is the value that land, that ecosystem services or natural capital provide to humans and particularly to business and to investors. And I'm not saying that there is no way to do this well. I know many people who are trying to do something that's very ethical here, but there is a lot of unethical activity right now in the investment community that is often practicing what we might call green colonialism, of people who are claiming the carbon credits for a forest and then kicking the indigenous people out, for example, or saying we're going to sell you carbon credits and oh, the price is going to go way up, when in fact the price has mostly gone down. My main issue with this is that the money is not going directly to the farmer, and the money is not coming from the community that is directly benefiting it, right? It's in these big global markets of carbon trading, and it's trading because some industry is still polluting, and then they're trading for that. And it's not just with carbon, it's also with biodiversity. You can destroy a wetland somewhere and then go to a biodiversity bank and buy the credits to destroy a wetland because somebody else is going to build an artificial one somewhere else. It's a wild west of a wild west of economics right now, as some of these big financial entities have discovered that this is potential value. This asset class, it has value that's more than the whole world economy combined, because they're realizing what we were talking about, that nothing is going to function if we don't have ecosystems functioning. So, but as usual, if something seems important, somebody's going to quickly try to figure out how to either greenwash it or make money off of it, etc. So I think that the right way to do this is that communities see the value in this and hire farmers to restore watersheds, restore biodiversity, just like you would hire a carpenter to put a new roof on your house. You don't need a middle person to make a huge profit over this and turn it into something global. It's actually benefiting your local ecosystem. So that's much. And we have one of our classes is about the economics of all of this and how does it work, both on the farm, but also how are people trying to make it work in other ways. So.
Yeah, Pascal, I feel your pain. I went through the same depression wave over my grad school, but don't give up. We need people with heart in a good place to help us change the system. I'm not saying that you need to go back to the formal studies, but don't give up. That's how we're going to change, one person at a time, one project at a time. So stay with us.
Great. Thank you all for your amazing questions.
Yeah, those were great. Those really, truly were great questions. They're not often quite such high quality questions.
Yeah, absolutely. And Didi, thank you so much for being part of tonight. We really, really appreciated it. So thank you for taking time to join us. So guys, remember our next webinar on April the 10th, Thursday, April the 10th, will be the Meet the Change Makers, which is Nicole and Nicholas. So this will be an absolutely fascinating webinar I certainly can't wait to introduce them to you. And we've been having we had the privilege of actually having some of his oil ourselves. So I'm having it at home. I have a spoonful every morning. So I'll be really interested to see what he says, and had the privilege of meeting him on his farm. So, is there anything else I need to say, Carla?
Just to make sure that you guys see the change in the hour. So next week will be 2 hours before we had today. So pay attention to adjust your calendar to not miss webinar 2.
Brilliant. And remember, you can watch this on some of the social channels. So if you missed part of it, go back there. Remember, we've got other social medias. We've got our TikTok, Instagram, Facebook. So please come and join us for the next amazing webinar. But really, thank you, Didi, for just an amazing evening. Really appreciate your time, and absolutely fantastic. Thank you.
I'm just loving these little loaves of bread that are floating.
Yes.
You've got everyone going now, Didi. That's it.
It's going to become a secret signal between us when we meet in other online spaces. People will say, why is there bread flying around?
There's still bread going. There's still bread going, Didi.
Let's go the next step. We challenge you guys to test our new TikTok channel, to do a video with some sort of bread trick, whatever you want to do with bread, and mark the school and Didi there.
Yeah, do add Didi Pershouse. We've got some fun ones from India, all over the place. Oh my God.
Oh gosh, look, you've set everyone up with it now, Didi. Look what's going on.
I'm getting hungry.
The screen's full of bread. And where do we go
Soil
from here?
Food Bakery. I love that, Bavia. Here we go.
And can we also, Carl, I think we need to thank everyone for joining us this evening. The community is what we all enjoy. And thank you all very much indeed for joining us on this great evening, listening to Didi. So thank you all very much indeed.
And thank you, the incredible staff that made our life easier here as well, Nick. You guys rock. And let's help us keep this community working and changing one bread at a time.
Thanks for having me. Keep an eye out for an email. I'm going to send around some resources to people. Didi, great to see you all, and hope to see you at the next event.
Yeah, thank you all very much indeed. Have a pleasant rest of the day wherever you are, or evening. And we'll see you at the next webinar, the 10th. Take care.
Don't forget to click that like button, subscribe to our channel, and ring the notification bell to stay updated with all our new videos.